This is the wood we use. We buy it from a distributor in Washington State. It's Sitka spruce. Comes from Sitka, Alaska. It's a very light, very strong wood. Stronger than steel by weight. We buy it rough sawn 4/4. First thing we have to do is run it through the joiner to get one flat surface. We've got an automatic feed which runs the board through the joiner. We don't have to put our hands over the knives. Keeps constant pressure on it so we don't get the usual dimples in the wood. Once through the joiner, get one flat surface. From there, goes through the surfacer, which will surface an absolutely parallel surface opposite the one done by the joiner. We're going to run it through the joiner. Got 4 speeds forward, 4 speeds reverse. Absolutely flat side on our board. The surfacer is an automatic feed machine. You can run up to about 3 boards at a time. We've got 17 of these boards. The boards are ready to go over to the gluing process. I'm mixing a 2-part phenol resorcinol glue. We're mixing by weight. It requires about 1 pound per foot of the hardener. We're mixing at a 5:1 ratio. The resin will be about 2 pounds.
Now, for how many blades is it?
This is going to be for 1 blade blank.
And how long is the blade?
This blade is 10 feet, this blank is 10 feet long. We'll have about 14 pounds of glue with the hardener. Watch me run out.
This is pretty nasty stuff, huh?
Terrible. It's almost as much fun as painting. I gotta open up the other bag. This scale is compliments of McAdams ShopRite.
It's a special scale or what?
It's just a standard grocery scale. Big investment of about $50.
Is there anything special about mixing this glue?
No, just keep a cover on it, otherwise it'll be all over the place. keep a bucket of water nearby. It is water soluble as long as it hasn't set up.
And how long, what kind of a pot life does this have once you've mixed it?
Well, depending on the temperature, at about 70 degrees, you should have a good hour, hour and a half to work with it.
Okay.
This is the time that the phone usually rings, and I have to go change to my glue pants. Spraying a little WD-40 on the crossbar so that the glue doesn't stick to them. Not that the glue wouldn't come off, but all it does is make it uneven when the next blank goes in and the laminations lay uneven. It also helps to put a little bit on the screws. Makes it easier to tighten them up. Okay. The glue press, as everything else in the shop, is 18 feet long. It's designed for the main duplicator, which is 20 feet long. The largest blade blank we produce is 18 feet. Each one of these stations has to produce 9,000 pounds of pressure. We have specially calibrated springs that were ordered within a tolerance of 5%. This is a simple lever mechanism. We put 900 pounds of pressure on each spring. We've got a lever action of 10 to 1, so at this point we get 9,000 pounds per foot. Over 18 feet we get about a 96-ton pressing capability. We're trying to stick to aircraft standards, 150 pounds per square inch. That's why the need for the enormous pressure. Well, we've got 17 laminations to glue together, and we use a very simple little glue spreader.
And I see you've got gloves on.
I wear gloves during all processes. Sitka spruce gives fantastic slivers. The straight grain of the wood allows it to sliver off in up to 2-3 inch long slivers. When you glue, glue is probably the least expensive component. Takes a little while to get started. When you glue, you always want to glue all surfaces. There we go.
You're really putting quite a bit on there, huh?
Well, as I said, it's the cheapest of all the things, and considering the investment in time and materials, I'd rather spill a little glue
Than be stingy with it.
right, than end up with a gap or a poor joint.
Now you're gluing both boards, and then you're going to put both boards together.
Right. That way you ensure that there's going to be glue on both surfaces. The only surfaces that aren't going to get it are the very outside edges that'll be up against the press. Once I get started on this, I don't like to stop until it's in the press and squeezed. I've never had a bad one, but in the summer months it tends to set up pretty quickly.
So you definitely don't want to have any stops or breaks during this process.
Just because of the weight of it and the size of it, I generally glue up 3 at a time and then slip them in here. Line them up at the edge. And do 3 more. I spent a lot of time listening to public radio doing this down here by myself. Boards for the blade. I'm going to leave the outer one unglued so it won't glue itself to the press. There we go. This is an unusual blank that the butt end is thicker than the tip end. So I've got this end spaced a little bit so that it is more central in the press. Okay. Now we'll switch gloves. I've got a spacer in here. This last one doesn't need to be this high. I generally start out with maybe the 3rd one from the end. Carefully lower it on there. Make sure all my laminations are down.
Now, why did you start out with the 3rd one from the end?
Well, if you start out with the end one, as you work your way in, you can get off a little bit, and it just centers it much easier. You want to have a little bit of space between each one of these pressing feet. And if you start at about the 3rd one in, it seems to work the best. On the longer blanks, I'll pick the middle one and maybe the 3rd one in from either end. On the little blades, the little 5-foot blades that we've been doing, we glue them up extra wide, and then on our 18-inch rip saw, we cut the blanks diagonally. That way we get 6 blanks out of every gluing. 6 foot times 3, 2 per 6-foot section. On these 9-footers we're doing right now, we've only got an order for 6 of them, and it doesn't pay to do all the extra work.
Now, there's no pressure on this yet. You just have those braces in place.
Right. What we're going to use to tighten them up is simply an automotive 3/4 inch drive air ratchet. It'd be very simple to convert these manual screws to hydraulics and run these down at a much quicker rate. Another financial problem kept us from doing that.
I'll Again, you're starting with the third one in.
Right, I'm just going to put a little bit of pressure on it. Next we're going to put the support. There. We find that there's too much flexibility in these and they tend to go to one side or the other, so we built this little spine that grabs a hold of them as we tighten. Keeps it all erect. Makes the...
It's doing something.
What?
It's flashing red. Does that mean the battery?
It's not. Tomorrow morning they'll be ready to go on the machine. As you can see, this is the laminated blade, blank, as it looks as it comes out of the glue press. This is a 17 lamination blade blank. All the laminations are approximately 3/4 of an inch. And after it comes out of the glue press, it goes through the joiner one more time. The bottom surface of the blank is run through the joiner to get a flat surface which will ride up against the carrier on the main duplicating machine. The steady rest carrier on the main duplicating machine will be holding this blank from vibrating during the machining process.
So it's real important that that bottom surface there be absolutely flat.
Right. The next step in the process is to cut the ends off. This blank is about 1 foot longer than the actual production piece. They will be cut on both ends, and then a steel extension will be added to both ends to save on the scrap. There's approximately 4 inches of scrap on either end.
Okay, now the tape is running. Now Tony's going to show us our hokey way to cut off the ends.
The one that
This is just another example of the terrific professional expertise that we have here.
this allows you to cut your fingers off at the same time. Because we could never afford proper equipment, we're using a super high quality Craftsman whole tablecloth. This is where I get to lift 125 pounds. And because the saw can't go through the whole blank, we just use our borrowed
Handy dandy dull chainsaw. Now we could thing.
This is the extension bracket for the tip end. I generally put this one on before I go into the duplicator machine. Requires a series of 3 lag bolts. This reminds me of Bob Vila. This old blade. Okay, now over that we put a small support plate which simply bolts on.
Is there only one of these?
Right. Butt end. On the butt end, the carrier doesn't follow all the way up to the butt edge, but on this end, the carrier wheels have to follow and transfer from the flat edge to the flat edge of the extension.
So what is the purpose of this? Just to add extra support?
This adds extra support. This, as well as the other end, removes 32 inches of what would have been wasted stock. The blade will end approximately here, and we'll have about 4 inches of waste on either end of the blade.
As opposed to several feet?
Oh, probably about 40 inches all total. These actually force into the top of the blade blank. And it's now ready to go on the duplicator. To add balance to the blank, as I put it on the machine, I'll put this follower, this is the follower that rides the center of the blade, or the bottom of the blade, excuse me, and I'll put that about in the middle. So when I set the blank on here, it'll be resting on here and on the tip end until I get the butt end extension attached.
So what you're doing then is measuring to the center of the blade?
Right. Okay, now, let me see, what else could I show? The rack and pinion drive of the machine, which you can see back here, is not only adjustable for the amount of advance the machine makes down the carriage, it also is adjustable by timers, forward and back. The machine does cut on the forward and on the backward stroke. At the transition period, where most blades make a dramatic change from the butt to the actual airfoil, we would like to take a much smaller cut to allow for less sanding in the final phases of the blade. Therefore, we measure what we feel is the most critical area, the most difficult sanding area, and we build a ramp.
That's what you're putting on right now there. So
Right.
that one changes for each blade?
Right. There's a different size for every type of blade. As the machine advances, this switch will roll up and contact on the ramp, which will set the machine on a different timer, which will allow a much smaller advance. When it gets off the other end of the ramp, we'll go back to the full stroke. The machine will be operating today at about 75% of its forward speed, and we'll be taking very small increments of probably a half of an inch. On the long stroke, we can cut a maximum of 1 1/16 inch on each stroke forward, each stroke back. This can be adjusted down to about a 64th of an inch.
No.
This is what I was doing before.
Do it again.
Okay, I've got the carriage, the steady rest, in about mid position. When I bring the blank in, it'll be resting on the steady rest and the tip end extension. Let's start with this. This is what does the actual work. This is a 12-inch carbide dado head assembly. There's 2 of them. This one corresponds blends identically with this tracing wheel, this one with this tracing wheel. As the machine advances, these are set up on cylinders, release cylinders. They're set almost in balance, and as the tracing wheels trace the pattern, the followers are cutting the blank.
Okay, we'll be able to see this better later on when we actually start to cut, correct?
Right. The benefit of this system over the other systems that are out there for wood are the fact that we're cutting both sides of the propeller at the same time. We are not moving the blank, turning it over, or changing it to cut the other side, losing our reference points. Who does it?
How much does this blank weigh?
Well, with this attachment, well over 100 pounds. It's one of the ridiculous things. Okay. Okay, we're putting the butt end attachment on. Fortunately, the hydraulic, or the air, is far away. These cylinders come down and hold the attachments.
How do you know you have it on there in the right spot?
Well, as of right now, I don't. Right now, I've just got it up.
So you're going to have to center everything now.
Right. Well, let me turn it right now. So wide. I'm going to drill it with 2 different drills.
Because it's so wide?
So thick.
So thick.
Be too much to expect to be able to afford the right drill. So, again, we make do.
Egg it, right?
Take it out. I don't have any bolts long enough, so I'll just modify the blank a little bit.
Why don't you have bolts?
I don't have time to chase and find 7-inch long, 1/2-inch bolts. So we'll just make do, as usual.
So what are you using there?
I'm using some 6-inch bolts that we sawed off to 5.5. Something like that. Get it good and tight.
Okay.
Now we can let the air off. Takes the clamps off, and with a simple plumb bob,
Is that like a gym bob?
sort of, and find out if the blank is positioned.
Are you
within-
going from the the trailing edge, or what is it on there?
I'm going from the very outermost position on the pattern to make sure that we're going to have wood
On both sides.
on both sides, right. We'll do it at the butt end and we'll do it at the tip end. Should have no problem on the tip end. Just check.
just measuring?
Checking for the height from the center, from the top of the steel bar
To your
to the string.
dental floss string.
Right.
That has to be exactly 4.5 inches.
4 1/4.
4 1/4, pardon me. Yeah, I can see the blade is straightening. It's straightening up as you're doing that.
A little bit more. This could be eliminated without much trouble. Simply having a follower on the pattern. Okay. That's where it belongs.
So once you have that center steady rest on the pattern, you can take off your dental floss marker.
Right.
Okay, so you only have to do that one time?
Yeah.
Or you'll have to do it again when you get when you move the steady rest as the wheels, cutting wheels, come closer to it.
No, there's actually an easier way for that part, which I'll show you later. This is the control center for the duplicator machine. All of it's activated by a magnetic starter. These 3 lamps indicate everything is running, everything is functional. If you have a blown circuit breaker or any other problem on the system, one of these lights will be out. We initially added these because without some sort of light on, without the cutter heads running, you couldn't tell whether or not the machine was engaged.
So it was basically a safety feature.
Right. The machine is fully automatic. It's now in the manual mode. The cutting heads can be turned on and off manually. We have a manual travel button here which activates to travel up and down the tracks, a manual travel for bringing the cross feed across and back. We also have what we call a travel jog override, which rather than standing here with your finger on the button as the machine comes all the way from the tip end back to the butt end, or vice versa, you just simply turn it to on. It'll run all the way back to the beginning and shut itself off. We've got 2 timers. These are the timers I mentioned with regard to setting the advance of the cut, the width of the cut. We also have timers for setting the trip on the forward and reverse strokes, as well as an SCR control for the speed of the forward advance.
Okay, so now you're moving the carriage up to the butt end so you can initiate cutting.
Right. When it's on the automatic override right now. When it gets back, it trips the switch. There's a switch on either side. It'll automatically shut off. These cutter heads will be going around at about 3,500 RPM. Okay. The vacuum system that was originally designed to work on this was always inadequate, was never functional. We finally decided just to shoot the sawdust on the floor. It does get quite a bit dusty in here, so I would recommend a dust mask and safety goggles. The first pass I'll make on automatic. After I get forward, I'll advance it, and from that point on, the machine will run fully automatic.
Now, why are you doing this first pass manually?
When it's cutting in the very first time, it's going to be taking an 1 1/16 cut, and I would rather, just from experience, watch it visually to make sure that everything is on the up and up before we let it go fully automatic.
Okay.
picture's gone. Well, here we are an hour and a half later. The blade is completely cut. I was busy in the other room. I heard the machine stop and came in. The last thing I have to do is put the center lines from the pattern to the production piece, which I do with the plumb bob again. We'll need these center lines for profiling. On the pattern, to make the entry of the two tracing wheels easier on the machine, we've simply built up the pattern and made a ramp mechanism so that when it comes on, it's a gradual on and a gradual off, rather than hitting a brick wall. On the production piece, you can see that this extra wood is going to be on here. The next process after this is going to be to take a profiler and profile the exact outside edge of the entire blade. Very simple process. I'm going to put the center line on the other end of the blade. All I have to do now is put the center line on the tip end of the blade,
So you hang a plumb line, find the center.
the center of the steel pipe.
Oh, I see. You have it hanging on the center of the steel pipe that
No, I
goes
have
through
it hanging on either side of the steel pipe.
so you make a mark.
make a mark on either side, and then divide that by 2, and I'll have the center line. Okay. It's hard to do this without getting in the way of the camera. All checking references are from center lines, so it's important to have them on here. There. Last step is to remove the 2 bolts holding the front extension.
And you do that on both ends?
Yeah, same those. I think I'll run the machine down a little bit
So that it's out of the way.
so it's out of the way of where I'll be working. It'll also catch the tip extension as I unbolt it.
Oh, you mean it's supporting the tip?
Right. Supporting this will support the bracket and the tip. I'll be on the other end grabbing a hold of it from that end, the heavy end. Most of these would be 2-man jobs, but I've figured out how to do it single-handedly.
So then the next step is to just cut that block off the tip?
We'll cut these off a little bit further from the end of the blade, and then with the profiler we'll profile the outer edge of the blade to its exact size by using another pattern. It takes about 10 minutes.
Go ahead.
This is the profiling part of the job. This is the profiling pattern. This is the condition the blade comes in off the main machine. We simply lift this onto this pattern,
You lift the blade.
onto the pattern, line the center lines, clamp it to the table. With this machine here, this is a 6-inch dado head on a high-speed motor. This tracing wheel is the same diameter as the cutter head assembly. This will trace the pattern. This will cut the outside edge of the blade to the same as the pattern. Okay. With regards to the attachment holes, all of the blades require some sort of attachment, most of which have holes that go at a right angle through the blade. All of the holes for this type are done with a simple drill fixture. 3 drill bushings, drill guide bushings go through here. We make holes larger than required and insert a steel bushing. This is a 1/2-inch slip fit for a 1/2-inch bolt. We do this for 2 reasons. One, to increase the surface area from 1/2 inch up to give us more of a contact with the wood. Second of all, to make sure that never does the bolt ever come in contact with the wood. Some of the blades, this one in particular from AEC in California, requires a much larger internal hole. This was a problem in itself. We had to drill a 2 5/8 hole, diameter hole 18 inches up this blade in order to insert an internal spring. This again required an additional machine, and that machine is what we have right here. These ways are machined ways just like on the main duplicator machine. We set up the blade on this table in a fixture, start out with a small drill, a fluted drill, go to a larger one, and eventually go to a spade cutter for the large hole. We can also do a countersink for a grease fitting. It's a very simple hand-fed mechanism. busy.
So it's moving down the track, you're moving it with the crank.
Right.
And the motor is just turning the drill.
Right. This is still in the hand operating mode. We could put a SCR driven DC motor on here, but we have a very small quantity of blades being made with this process. We're still using this in a manual mode. We've got a manual hand crank to advance the screw. This could very easily be made to operate automatically with a DC motor and an SCR drive. Well, this is the last stop along the propeller line. This is our checking table. It's also 18 feet long. It doubles as a pattern building table. We build all our patterns on this table. Hard rock maple top was finished and surfaced to an accuracy of 1/2 of a millimeter over its entire 18-foot length. The blades after the machining process and after the painting process come in here, get bolted in this vertical headstock. We do have an adjustable tip stock, and with double guillotine fixtures, each blade is checked at stations 12 inches down the blade. The accuracy of our blades has been about 1/4 of 1 degree accuracy on the angle of attack, and we've been holding a contour accuracy of about 40 to 60 thousandths.
I know it's going to be something dirty.
Well, now that we're all done with this, I'm going to go home and I'm going to do all those terrible things that I've been thinking about during all of this boring process to my wife. All of those things that she loves.
I thought you were going to say we're going to do it on top of the checking table.
It wouldn't be the first time. Well, here's one of the blades we made. This is a 12-foot 7-inch blade used by Jacobs Wind Electric. You can see here, this one's finished clear. You can see the laminations. You can see the clear grain of the wood. This blade weighs about 25 pounds.
How long is it?
12 foot 7 inches. The longest blade we've made to date is 15 feet.
Quite a saw.
With this 18-inch diameter carbide rip saw, we take one of our double blanks and with stage nail this little pattern to the side of it, run it through the rip saw, and we end up with a trapezoid-shaped blank. This saves us on the wear and tear on the duplicating machine. We've got a wider butt, narrower tip. We get 2 blanks out of every gluing of this operation. Okay.
Keep this stupid car out of here. Oh, shut that fucking thing off.
When you're mad.